What's up, guys? It's probably the last video I'll make for the day, and I promise to have the rest uploaded by Monday or Tuesday this week. So when you're back in school. Um, this is not gonna be that bad, I guess. I don't want to scare you guys in this section. Um, it's not an easy topic. This is trig sub. The last one wasn't technically trig sub, but this one is. So I think can really help you guys, and you do want to use the book for this section just to refer to. Um, books are powerful. They have all sort of the reference points. So let me show you guys. So we're in 8.4, and if you open the book to 8.4 and go to page 540, this is essentially what's going to guide us in all our decisions. Okay. So you see this. Okay, so we're looking at problems like that. This is very important. The form has to match. When we see a squared minus x squared, we're going to make this substitution. Now, a is going to be a number, so it might be like 16 minus x squared. So what we think about that is 4 squared minus x squared, right? 4 is a, x. If we flipped it, if we had x squared minus 16, but let's say 4 squared, then we're going to use this substitution. We're going to let x be a secant theta, okay, or u rather, okay? That's half of it. The other half is when we make substitutions, um, notice we're creating this variable theta out of nowhere. We have to be able to substitute for dx as well. And so we're going to have to get d theta. Okay, so let me just show you some example. You can just jump to the problems, but so you definitely have to have this printed out just to refer to. Okay, make sure you know where these things are coming from. Okay, so basically we have, right? I literally just showed you guys one chart in the section. That's all we need, right? We don't need all the other stuff they go through. What we have is, forget about the square root. We have an x squared minus a 10 squared. Okay, so that's x squared minus 10 squared. So a is 10. But what substitution does that look like according to the book? Well, if we go back, that looks like the one when you have x squared minus a squared. So that's going to be secant theta. So our substitution would be x is a secant theta, right? We're creating this theta. So this is the weird part out of nowhere. And our a is the number that got squared, which is 10. So it's 10 secant theta. So it's b. Now, in this problem, they don't show us what that does, right? But remember, this whole chapter is about taking antiderivatives or integrals. Okay. So that's the hint. So again, what format? Well, if you don't know, 441 is 21 squared. Okay. So we have something that looks like this. So according to that, what would our substitution be? Now this is a squared minus x squared. If you go back to the book, I'll cheat here. We have a squared minus x squared. Our substitution is x is a sine theta. Okay. So our answer would be 21 sine theta. So this one B. Okay. Okay, cool. Now we finally see why they're doing it. Now notice, guys, this is a scary looking problem, mostly besides the fact that we have a square root in the denominator with stuff going on. They also have, let me show you, they also have this right here. And now that's going to be painful to have to plug in. But whatever, we're just going to do it. But what we're really banking on here is that that table is all we need. So you can see we have 6 squared minus x squared. And this is the last time I'm referring back to the book for this because we have to memorize these. Okay. That's going to be a sine theta, right? So my substitution is I'm going to let x equal 6 sine theta. Now, what we haven't gone through yet is taking substitution part for the dx. So if I differentiate both sides, I get dx is 6, what's the derivative of sine? Cos d theta. So what that means is, this is probably the most important part, again, of Calc 2, is where I see a dx, I'm going to substitute this 6 cos theta d theta, right? So up here, this is funky, but this is very component-based technique, right? I literally put everything that I got. So if I have 6 cos theta d theta, that has to go up here in the numerator. In the denominator, what happens? I make a substitution where I see x. This is brand new. This is where you're going to get stuck. I still have this 36, but this is a magical technique. If you're into like what is it, Dungeons and Dragons or Magic the Gathering, this is literal magic here. So where I see x, that component is going to get squared, and that would be 36 sine squared theta. Now you're looking at this problem like, what the heck is going on? Okay, well, bear with me. Bear with me. Okay. Watch what happens. This is the magic part. Okay, so I have 6 cos theta up here, d theta. Now, if I get funky down here inside the radical, I could say they both have a 36. That's nice. And now watch the magic. 1 minus sine squared. And you're like, where's the magic? I don't see it. Sell me this pencil, right? No, watch. That simplifies to this. And I can split this, right? I can split this as square root 36 times this as a square root. But 1 minus sine squared is just cosine squared. So you see the magic starting to happen. And then let me show you the rest. And so notice I'm not doing anything to the top until I have to. And square root of 36 is 6. Square root of cosine squared is cos. And then they gave us a beautiful problem. Everything cancels except for d theta. So I really just have this, but we're not out of the woods yet. Okay. Now imagine if that was antiderivative of dx, we would just get x. So in this case, we just get theta. And unfortunately, that's not going to be an answer choice, right? This is also a definite integral. It wants us to plug in. What we have to recall is, what did we say theta was? Well, we didn't say what theta was. We said x was 6 sine theta. And so we can find theta using the most tedious pre-calc techniques, right? If I divided by 6, I would get x over 6 is sine theta. And how do I get theta by itself here? Unfortunately, we have to take sine inverse or arc sine. So I get that theta is the arc sine of x over 6. And that's definitely a calculator problem, right? But that's what we would do, is we would plug in 0 into the calculator, do sine inverse, and then plug in that, and you get your answer. Okay, you're probably like, oh God, this is what we're doing. Yeah, this is Calc 2, guys. This is why they say Calc 2 is hard. A lot of steps, a lot of substitution and back substituting. We have to always be aware and mindful that when we do a substitution, we also have to take derivative with respect to new variables, substitute dx. There's a lot moving parts. So let's talk about this one. Well, let's go back to our chart. I said it wouldn't, but let's see. We have something minus x squared. That's going to be sine theta. Okay. So x, hold on, sorry. X is what's a? Well, 6, right? Because 36, 6 squared. But remember, this is the most important part of the trig sub. This is trig substitution, right? We're basically using properties of trig integrals and looking at at what we have and saying, hey, that looks like this, but if it was in trig, okay, you'll see more of what I'm getting at later. But so um, we say, oh, before I do that, that's exactly what I'm saying. We have to take the derivative of that. So we say dx is 6 cos theta d theta. Okay. That means this little guy right here, who seems harmless, unimportant, is going to get substituted for this ridiculous thing, right? Don't panic though, because these will always cancel nicely. Now what I do is I come here, have an antiderivative sign. Where I see x, or x squared, I'm going to substitute this for x. If I square that, I get that. But be aware, outside here, instead of dx, we have this. And this is where you'll make mistakes. You're going to convince yourself that, oh, we're not supposed to have that. I'm going to get rid of it. No, that's what gets substituted for dx. In here, this is where the magic's happening, right? We can say, well, this is square root 36 times 1 minus sine squared, but this 1 minus sine squared is cosine squared. So this really simplifies to 6 cos theta, right? When I take the square root of 36, I get 6. When I take this, if I think of this as cos squared and I square root that, I would get cos theta. But we still have this. So we have the same thing out here because that's our dx. And that would be 36 cos squared. Let's finish that. So then what we're really doing after all these steps is doing this, the theta. And if you recall from 8.3, we could use the half angle formula. So we could do 36 times this. And we're not out of the woods yet, but that's not too bad. Remember, I showed you how to do this. It's a U sub. And then just remember, we made the substitution that x was 6 sine theta. So you have to get theta by itself here. It's x over 6 is sine theta. So theta, when I substitute after integrating this, I would get arc sine x over 6, okay? So you can see right here, we have 36 and a half. So when I do that, that's 1, and the other one is this. But what I'm pointing out is when you integrate this guy, you're just going to get 18 theta, but that theta is still the same substitution when you back substitute. So again, a lot of moving parts. Okay. Now, if you're struggling at this point, but you're kind of getting it, that's where you should be. At least in the video, you should be like, okay, you have to, where do you start, right? Where do we start? We look in the book. What form does this take? This is going to be, well, this is 6 squared minus x squared, right? And that's what substitution? That's x is 6 sine theta. You immediately say, okay, what's dx? It's 6 cos theta d theta. If we jump in head first this time, this is what it looks like in real time, right? You get x squared, but that's this, right? I'm squaring this. Down here, I have this. Simplifies to, we have our d theta as well. So we have this out here. There we go. So this becomes 6 cos theta, but notice this cancels nicely. And so I'm going to write over here, we're just integrating this. And again, that's a half angle substitution. So that's the only time 8.3 really comes in handy, although those problems were somewhat interesting. So here we go. Okay. What form? Again, we have the form of sine, right? So what is 225 a perfect square? It is 225. It's 15 squared. So my substitution is x is 15 sine. Immediately do dx, 15 cos theta d theta. And so this becomes 15. Maybe you like when I go fast, I go slow often. So go a little faster here. 15 cos theta over 225 minus 225 squared, which is hopefully everything cancels. That's what you should be thinking. You're like, I hope I get a 15 cosine theta. I hope I get a 15 cos theta in here so they cancel. And what do we get? We got 225 times 1 minus sine squared, and that's going to give us, if you simplify that, this is, remember, cos squared. So we got 15 cos theta over 15 cos theta, which is what we want. D theta, that's just one. Integrate. But remember, we're not out of the woods because what's going to happen is when we integrate d theta, we get theta. You have to come back and substitute for theta, which is an arc sine. So instead of theta, it's actually arc sine x over 15, right? Do the math on that and you'll get, do the trig rather. Okay. Okay. So, okay, crazy, but let's see what form does it take when we have a number, right? You can easily identify that 144 is perfect square. That's 12 squared. That reminds us this is that type of problem, right? Whatever's going on with the 5x squared or squaring the thing in parentheses, we'll deal with that. But where we start all these problems is in the book, and we say, okay, that's going to be a tan sub. The first time we've seen tan. So since this is 144, our substitution is going to be x is 12 tan theta. Immediately calculate dx, and that, remember, derivative of tan is secant squared. Getting bored yet? Probably, right? But this is kind of fun. Honestly, I think you guys will enjoy these as much as you hate them. So as much as you hate this problem, you're going to love it, right? It's the yin and the yang. It's love, hate, whatever. Um, so what my substitution is going to be is 5x squared, but that's 5 times 12 squared, 144 tan squared. Uh-oh. And then down here, we have 144 plus, remember, this is x, so it's square 12 tan, that's 144 tan squared. And then that gets squared. Oh my gosh, right? This whole thing is squared also times this. So if you're doing this problem and you get something that looks insane like this is the right, um, progress in the problem. Okay, this is how it should look. Okay, just remember when I'm erasing this, we have to be able to back substitute what we picked for x. So that, because we're going to get an answer in terms of theta. This is a trig sub, just like with u sub. Okay, well, what do we do? I don't know. Let's see. We have, well, I don't think we need the 5, but we have 144. Uh 60. Gosh, this one looks rough, right? Let's see. Um, hmm, got stumped on this. Well, not completely stumped. Let's walk through it. Let's see if they help us here. We know this was our substitution. Okay. This is what we're asking. Okay. Just, is stuff supposed to cancel? Hmm, hmm, hmm. I'm wondering if, see, tan squared sine squared over cos squared. This is a gnarly problem. Let's look through the help. Let's just look through the help. Why not? I'm wondering if I'm just not seeing something. There's 17 parts, yeah. So we should get to here. I want to see what they do once they get to that. Oh, these are different numbers, but whatever. Let's see. So right here, guys, where it says simplify the integrand, this is where we're at. Um, there was a step. Okay, so we needed that step. So where we're at is fine. So recall, this is why I don't love these problems, guys. I don't think this would be a good test question because it's like, by the way, you remember this from 15 years ago when you were in high school and you didn't care about trig, right? But here we have to be able to recall that secant squared is equal to tan squared plus 1. So that's going to affect what we do down here, and that's going to actually cancel with this. And then let's see. So let me erase some stuff. I'm sorry. With the trig stuff, you have to write all over the place because it's letters and words and not just numbers and stuff. So what's going to happen is we have, let's see, we have this up here. We're not really interested in that yet because this is going to be left over. But what we're hoping is that stuff cancels with this guy out here. And it will, because look, if you pull out a 144, you would have 1 plus tan squared, and this is going to be secant squared. So we got, just running out of space. So you can follow the help too. It's going to do the same exact thing I'm going to do, but it's getting a little crunched in here. So we have this. Let's see. We have 144 times secant squared, and this is squared. So you can see, let's see, we have a secant squared up here, and we're gonna have secant to the fourth down here. So that's gonna cancel and leave us with a secant squared in the denominator. So hopefully, this is much easier on paper, guys. That's all I'm saying, because my steps just disappear and I don't know. So let's say we'd have this up here. And we have a 12 secant squared. That's going to cancel with one of these. So this goes away and this goes away. So we have a 12 left, d theta, and we have a 144. So problem should work out to this. And then this is a u sub. Well, no, it's not. It's not. Sorry, I lied. Let's see. Over secant squared, dividing by secant squared is the same as multiplying by cos squared. So this would be, I hate these numbers, but okay, this 144 is squared as well. So we have 5 times 12, 60 out here. We have 144 tan squared. We have a 144 squared. This is just, I don't know why they picked these numbers. So this cancels, this goes away. Over 144. But instead of writing over secant squared, I can bring that up as cos squared. And then up here, I'll show you what happens. Tan squared is sine squared over cos squared. And if I multiply that by cos squared, that cancels. So this becomes 60 over 144 antiderivative of sine squared. And this is the half angle substitution from 8.3. And remember, we have to solve back for what we picked for x. X was 12 tan theta, so you get theta by itself, and you see theta is tan inverse x over 12. So ultimately, when we're done, when we get theta, whatever this integral is, we'll substitute that back. Okay, ugly, ugly, ugly. But good problems as at the same time. Okay. So you can tell I'm tired, right? I've done 4 videos, should do 5, we'll see. But it's not about me being tired, it's about you guys getting something from these videos. So if they help, awesome. This is tan again, right? We have 7 squared plus x squared. That means substitution is x is 7 tan theta. Immediately calculate dx to be 7 secant squared d theta, right? And so where I see dx, I'm going to put that mess. It is a mess, but it's our mess, right? It's what we get to work on. Down here, you can't let this 3/2 throw you off. That's just 49 plus 49 tan squared You know, we just learned the hard way that if we're not keen and aware that there's other trig identities in play here, not just Pythagorean from sine squared plus cosine squared is one, but there's the secant squared one. We're not going to see what the next step is. Unfortunately, that's how some of these problems, um, what they boil down to. So basically, oh, we have our d theta. Oh, we already did that one. Good. Oh, we already got it. Good. So what happens, or how this simplifies, secant squared theta d theta. I have 49, but I'm going to pull that 49 out, and that's just times 1 plus tan squared. Remember, this is secant squared, but this is also 3/2. Okay, so what we get is hate running out of space. Some of you guys are watching this laughing, like, but it's annoying. I wish I had a giant whiteboard. I used to teach like that. Okay, so we have this up here. We have this down here. Now, don't just cancel because we have this 3/2 out here. So let's talk about how to deal with that. Well, I have to be careful not to cancel. When I have a 3/2, I can think of that as a square root and a cube, right? The 3 is like a cube, the half is like a square root. So I can actually square root this first. If I do, oh, can't write with an eraser. And if I do that, I would have, if I square root that, I'd have this. But I still have this cubed up here. Now I have to cube the 7, not just the secant. So it's going to be 7 secant squared over what's 7 cubed, 343. Secant cubed theta, secant squared over secant cubed, they cancel. 7 over 343 is 1 over 49. Now I really want to point this out because you're probably quite likely hating the aspects of trig that are thrown into this problem. You're like, why are you asking me trig? Why are you asking me trig? I'm not asking, the book is, right? But I really want to point this out just so you see what not to do. Don't try to integrate secant, right? This is simpler than that. If you see it, you're probably smiling. The 49, who cares, right? But recall that 1 over secant is the same as cosine. Okay? And so all we're doing here is integrating 1/49 cosine of theta, but that's 1/49 sine. Okay. When you integrate that and then substitute back for whatever theta was, this was tan, so it'd be arctan of x over 7. So this becomes 1/49. You're gonna laugh. You're gonna laugh. Sine of arctan of x over 7, right? Crazy answer, but that's what it is. And I'll show you that that's what they get, just to prove it to you. And clear all this. So you're gonna get some crazy thing with multiple trig. But watch. 12 parts. Okay, show us. Right, their problem looks identical, so they should get the same thing we got. Um, did they? Did they? No. Yeah, they did. Right, right here. They get the sine. Look, what do? In this case, they draw a triangle, so you can do that. But I want to point this out and make this clear. The answer that we got is right. So you don't have to do this. For the credit in this problem, you're going to have to follow and do the triangle. But um, so we got something like that. Ours was tan of theta is x over 7. So just remember from pre-calc, you can draw a right triangle opposite over adjacent. And the Pythagorean theorem says this is square root of x squared plus 49. And so if your answer has sine, you do, this is theta. Sine is opposite of hypotenuse. So you put x over this x squared plus square root of x squared plus 49. But it's the same thing, guys. So however you want to write it, it's fine on the test. So if you wrote it the way I did and the computer marks you wrong, I'll give you full points because your answer's right. Anyways, that's that. And yeah, it's a lot today. This one I'll leave you guys to do because I'm a little tired, but Again, I hope this helped. I may make one more just to stay a little bit ahead in this chapter. But I hope you enjoy the video and it's helpful.